Winter was once the enemy of agriculture, a season when frost choked harvests and buried millions of tons of crops. Yet today, in the hands of science and technology, that same brutal cold generates more than 300 billion USD in just 3 months, transforming winter produce from a weakness into a strategic asset of the global economy. In today's video, Agriculture Insight takes you into the paradox of winter agriculture, where humanity overturns natural limits and turns the very season that once suppressed production into a decisive advantage. From seemingly barren, inhospitable fields, science, technology, and precision management now enable agriculture to operate through winter, delivering massive output and reshaping the global food landscape. First, we step into winter rose gardens, where even in the harshest cold, technology forces blooms to open on schedule, turning fragile petals into 10 million USD in revenue every single day, a feat possible only in modern agriculture. Winter does not put roses to sleep. Instead, it becomes the season that determines the value of the entire industry. As outdoor supply dwindles, greenhouses turn into arenas of technological competition, keeping roses blooming precisely on demand. Inside these sealed greenhouse structures, technology operates like a living brain. Sensor networks silently monitor every growth parameter, while drones skim just above the plants, spraying nutrients with milliliter-level precision. When buds reach the ideal commercial bloom stage of 70 to 80%, workers immediately cut each stem using specialized shears, executing firm, precise motions to avoid bruising the stem or damaging the petals. Within just 30 minutes, the bouquets are rapidly chilled to 2 to 4 degrees Celsius, slowing plant respiration and preserving freshness. From there, each rose quietly enters the global supply chain, blooming at exactly the right moment in the hands of millions of women across continents. In contrast, winter roses grown outdoors follow a completely different path. With no sensors or machines, harvesting is done entirely by hand, an art that demands absolute precision. When the fragrance reaches its peak, workers move through the cold morning mist, separating each petal according to the flower's natural blooming order. Thousands of blossoms are required to produce just 1 kilogram of fresh petals, a precious raw material that is distilled the very same day. Here, beauty is no longer measured by appearance, but by pure scent, the very soul of the world's most luxurious perfumes and cosmetic creations. Leaving behind the winter rose gardens of Florida, we now turn to Japan, where persimmon orchards enter a short but explosive winter harvest season, generating more than 300 million USD in revenue in just a few weeks. In October, as entire orchards shift into vivid shades of orange and red, the golden harvest season officially begins. During this window, each persimmon variety demands a distinct harvesting method. For thick-skinned, low-canopy varieties, growers spread soft mats beneath the trees and gently shake the branches, allowing the fruit to fall safely without impact damage. In contrast, fully ripe, thin-skinned persimmons must be picked entirely by hand, one fruit at a time, to preserve their smooth, taut skin. For ancient persimmon trees, reaching 6 to 7 meters in height, workers climb ladders or the branches themselves, using long-handled shears to cut each fruit with precision and safety. Immediately afterward, the persimmons are carefully sorted either on-site or within the same day. Soft, sweet fruit is sent directly to market for fresh consumption, while more astringent persimmons are transferred to processing facilities to be made into air-dried hoshigaki. A single persimmon can be priced at up to 50 USD, but behind that value lies an entire chain of manual labor, strict selection, and refined processing techniques, all unfolding in the harsh winter season, where even the smallest mistake can cost an entire harvest. In the final days of the year, while much of the world is bringing the agricultural season to a close, a new journey begins in Yamagata Prefecture, Japan. The journey of apples sleeping beneath the snow. Here, tens of thousands of premium Fuji apples are harvested entirely by hand, then transported to snow-covered mountain regions. Instead of being stored in conventional artificial cold facilities, these apples are buried deep in natural snow, forming a one-of-a-kind biological cold cellar. With stable temperatures hovering around 0 degrees Celsius and high humidity provided by the snow, the apples continue to mature in silence, converting starch into sugar, retaining their crispness, and developing a clean, delicate sweetness found only in Yuki Ringo, Japan's snow apples. By late March, when the snow begins to melt, each crate of apples is carefully unearthed. Production is extremely limited. It takes thousands of apples to select a single export-grade batch, which allows snow apples to command prices 3 to 5 times higher than ordinary apples. Japanese snow apples, Yuki Ringo, are not merely a premium agricultural product, but a symbol of a farming tradition defined by precision, patience, and deep respect for nature. In ancient Egypt, garlic was not just a seasoning. It was used as payment for the workers who built the pyramids. Today, what was once known as white gold has become one of the world's most important winter crops, with global annual production reaching nearly 30 million tons. Each year, as winter enters its final weeks and the dry cold begins to retreat, garlic reaches its critical harvest window, when the leaves have fully yellowed and the bulbs achieve optimal dryness. At this precise moment, garlic is not harvested by the massive machines used for potatoes, but by compact, specialized systems engineered for accuracy down to every movement. First, a slender blade glides beneath the cooled soil at a calibrated depth, gently lifting the bulbs in a controlled motion. Next, a vibration mechanism activates in a steady rhythm to shake off excess soil, while the dried stalks are cleanly separated and returned to the field. Under favorable conditions, a single machine can harvest 10 to 20 tons per day, transforming winter fields into a steady, uniform flow of raw material for an industrial processing chain that operates with precision and decisiveness. In the biting winter of South Korea, where temperatures can drop below -10 degrees Celsius, strawberries still ripen into vibrant red perfection inside smart greenhouses, places where robots, artificial lighting, and algorithms completely replace human hands. Inside these winter greenhouses, strawberry harvesting robots do not rely on touch, but on data and algorithms. First, the machine moves between strawberry rows along fixed rails, maintaining a steady speed to minimize vibration and stress on the plants. Next, camera systems and machine vision scan each cluster of fruit, analyzing red color intensity, surface gloss, and size to precisely identify ripe strawberries, achieving accuracy rates of over 90%. The robotic arm then brings its gripper close to the stem, adjusts the approach angle in a split second, and makes a clean cut to avoid bruising the soft flesh. Each strawberry is separated intact and gently placed into individual compartments within a collection tray. Finally, the robot repeats this cycle thousands of times per day, harvesting dozens of kilograms per shift, transforming manual labor into a harvesting process that is precise, clean, and perfectly uniform. Known as the sugar factory of winter, sugar beets are the silent backbone of the temperate sugar industry, contributing nearly 20% of global sugar production. Sugar beets are typically harvested when temperatures hover around 0 to 5 degrees Celsius, a unique window when most other crops have already reached their growing season. As a result, the sugar beet harvest unfolds in the cold, when fields are largely absent of ordinary agricultural activity. When the harvesting machines enter the fields, the entire process is organized like a continuous production line. First, high-speed rotating blades at the front cut away the green tops, clearing the field surface for the lifting stage. Next, the lifting system descends to a precisely calibrated depth, separating the beets from the heavy soil and raising them with evenly distributed force to minimize surface damage. The beets are then carried onto vibrating conveyor belts, where soil, stones, and excess roots are shaken off step by step. The cleaned beets continue through multiple conveyor levels before dropping into a large onboard storage hopper. Once the hopper is full, conveyor systems unload the beets onto waiting trucks along the field edges, transporting them directly to processing plants. Throughout this short but intense harvest season, machinery, transport trucks, and sugar factories operate around the clock to ensure the entire crop is processed in time. Considered a new spearhead of winter agriculture, celery has established its position thanks to stable yields, high harvest value, and consistently strong market demand. The harvest season typically runs from November to February, when daytime temperatures ranged between 5 to 10 degrees Celsius, ideal conditions for celery stalks to become crisp, firm, and well preserved after harvest. In the fields, human labor remains an irreplaceable first link in the process. Workers bend close to the rows, cutting each plant cleanly at the base with swift, precise motions to keep the stalks straight and the leaves intact. Just seconds later, the celery is placed onto mobile conveyor belts running alongside the field, marking the moment when manual labor hands over to mechanization. From there, machinery accelerates the entire operation. Horizontal blades cut in uniform passes, while rotating knife systems precisely separate leaves from stalks. Every movement flows seamlessly, forming a production line stretched across the open field. Harvesting machines solve the challenges of speed and labor intensity, but their efficiency depends on tightly controlled parameters, since even minor deviations in speed or pressure can bruise and damage the celery stalks. From human hands to precision mechanics, the entire field operates like a winter machine, rhythmic, efficient, and calculated down to the finest detail. Leaving behind the lush green celery fields, we turn into vast cabbage farms, where these nutrient reserves of the cold season are being harvested at remarkable speed thanks to the arrival of massive machines. Once the machine enters the field, the rhythm of manual labor is replaced by a seamless mechanized process. Hydraulic cutting blades at the front operate swiftly and decisively, cleanly slicing each cabbage in a single precise motion. Immediately afterward, conveyor belts continuously lift the heads, while automated systems remove old and dirty outer leaves along the way, performing preliminary cleaning before collection. As a result, cabbages move straight from the field into storage bins with minimal human intervention. Each machine can harvest 8 to 12 tons per hour, dozens of times faster than manual labor. Equipped with sensors, anti-sinking systems, and self-leveling mechanisms, the harvester moves steadily across soft ground, transforming the entire field into a precise and highly efficient industrial harvesting line. Kiwi is one of the most iconic brand twists in global agriculture. Although closely associated with New Zealand, this fruit actually originates from China, where it once grew wild and was known as the Chinese gooseberry. The turning point came in 1904, when a New Zealand school principal brought the first seeds home. There, the fruit was renamed after the kiwi bird, a name strong enough to carry it out of the Asian mountains and onto the world's fruit map. Today, China remains the largest kiwi producer, accounting for more than 50% of global output, while New Zealand contributes only around 7%. Yet through clever rebranding, strict quality standards, and mastery of cold chain logistics, New Zealand dominates the premium export market, turning a Chinese fruit into a symbol of value and quality. Few people know that there are over 50 kiwi species, most of which are inedible or yield small, sour, and hard-to-store fruit. The global market, therefore, revolves around just two main varieties: green kiwi, with its classic sweet tart flavor, and gold kiwi, prized for its rich sweetness and premium image. These two have defined the modern kiwi industry. Interestingly, kiwi is also one of the most nutrient-dense fruits on Earth. It contains nearly twice as much vitamin C as oranges, along with serotonin and antioxidants that naturally improve sleep, a kind of healthy sleeping aid born from nature itself. To create such achievements, we must swim against the current, back to the very origin of the kiwi, where the story doesn't begin with ripe fruit, but with a cultivation system engineered to perfection in every detail. The life of a kiwi begins with its trellis system, the most crucial foundation of the entire orchard. Before planting, farmers erect concrete or wooden posts about 1.8 to 2 meters high, connected by tensioned steel wires to form a horizontal framework above the ground. Since kiwi plants are climbers, their entire growth depends on how well they can cling to and spread across this structure. After about 200 days, young kiwi vines start to seek support on their own, winding gently around the posts as they climb upward to maintain balance. When the canopy closes over the trellis, the kiwi orchard enters the most delicate stage of the entire season: flowering and pollination. Male and female blossoms grow on separate plants, and each flower stays open for only about 4 days. To avoid leaving pollination to chance, large farms combine natural bees with mechanical pollination devices, machines equipped with upward-facing nozzles that blow fine clouds of pollen across the vines. Pollination robots move along the rows, releasing pollen collected from male plants precisely onto each blooming female flower. This method ensures the pollen reaches the stigma accurately, compensating for cool, damp days when bees are less active. In those brief moments, the future of the entire kiwi harvest is almost decided, before the petals close and the young fruit begin to form. Similarly, the irrigation and fertilization systems for kiwi follow the same upward spray principle. Because the vines have dense canopies and tall trellises, all equipment is designed to deliver water, nutrients, or micronutrient solutions as a fine mist rising from below, spreading evenly across the undersides of the leaves and around the root zone. High-pressure sprayers generate powerful airflows that drive the droplets deep into the canopy, reducing waste while enhancing absorption efficiency. Every year, from around March to June, kiwi orchards enter the most critical stage of the entire growing season. It is a brief but intense period when the fruit is not harvested at full ripeness, but instead cut from the vines while still firm, at the precise biological point that allows it to be stored and transported over long distances. To determine the exact harvest time, kiwi growers don't rely on color or softness. Instead, they measure dry matter content and Brix level inside the fruit. When the dry matter exceeds about 15% and the Brix level reaches approximately 6.5, harvesting can begin. The rare balance point where the fruit can continue ripening after picking while remaining stable for extended cold storage. For premium varieties like Zespri Sungold, this process still depends almost entirely on human hands. Farmers physically assess each fruit's weight, firmness, and condition before every cut, because harvesting even a few days too early or too late can sharply reduce the crop's value. However, as production scales up, fully manual harvesting creates an enormous demand for labor within a very short window. As a result, mechanization is gradually being introduced to support large-scale orchards. Whether harvested by hand or by machine, kiwi fruit are immediately collected in large specialized bins right in the orchard. From there, they are loaded onto trailers and transported out of the farm as quickly as possible, heading straight to central packing facilities and cold storage warehouses, where the next stages of grading, preservation, and processing take place. From the very first stage of intake, kiwi bins are opened gradually according to a pre-calculated rhythm, allowing the fruit to flow out in a controlled stream rather than tumble out all at once. As they move onto the tiered conveyor system, each kiwi rolls gently across a layer of soft rubber, spreading into a single, evenly spaced line that ensures a smooth flow and minimizes impact. This deliberate slowing down by design throughout the process helps factories reduce kiwi damage by more than 7% each year, saving hundreds of thousands of dollars in losses. Along this steady flow, clusters of soft, flexible fibers lightly brush the surface of each fruit, removing residual soil while rotating them at different angles to expose every side. At the end of the line, workers stand along the conveyor for an initial quality check. They don't just remove scratched or misshapen fruit, but also detect subtle signs machines might miss, such as abnormal softness, newly formed abrasions, or early symptoms of skin disease. In practice, each shift can intercept hundreds of substandard kiwi fruit right here before they move deeper into later processing stages. After being cleaned and stabilized in flow, the kiwi fruit enter an automated machine vision sorting system, where both speed and precision reach their peak. Each fruit is guided into a separate channel, evenly spaced to avoid overlapping during movement. Above the conveyor, clusters of high-speed cameras capture images from multiple angles under tightly controlled lighting, accurately recording each kiwi's shape, size, and even the tiniest surface imperfections. In less than 30 seconds, the image data of each fruit is analyzed, compared, and classified. Immediately afterward, the mechanical sorting system directs every kiwi into the correct lane, from premium-grade fruit for the fresh market to those destined for processing. With a standard configuration, the line can handle over 10,000 kiwi fruit per hour, while maintaining an almost perfect level of consistency. After sorting, the kiwi fruit move on to the packaging and labeling stage. On the automated line, each fruit is placed into a molded tray that holds it securely in place, preventing rolling and collision. Label rolls rotate continuously, releasing pre-printed traceability stickers that are precisely applied to the surface of each kiwi by synchronized robotic arms moving in rhythm with the conveyor. At the same time, the automatic tray packing system arranges the kiwi fruit into padded cartons, maintaining even spacing between each fruit. With a standard configuration, a single line can process over 20,000 kiwi fruit per shift, ensuring every piece is properly secured, accurately labeled, and fully prepared for cold storage and onward transportation. Inside the quality control lab, each batch of kiwi fruit is analyzed right after packing. Technicians cut samples and measure flesh firmness using a pressure tester. Values between 4.5 and 6.5 kilograms F indicate the fruit has reached the ideal technical maturity for storage and continued ripening. At the same time, a Brix meter determines soluble sugar content, while moisture and dry matter levels are checked to assess freshness and shelf life. All data are entered into a traceability system, creating an electronic profile for every batch. Thanks to this process, only kiwi fruit meeting strict standards of structure, sweetness, and biological ripeness are cleared for the next stage, cold storage. When trays of fresh kiwi fruit leave the cold storage, traveling thousands of kilometers in atmosphere-controlled containers to reach global markets. Another part of the harvest, the fruit that falls short of export standards, quietly takes a different path. These kiwis enter the pressing line, where they begin a new life cycle in a different form, as pure kiwi juice. To make juice, kiwi fruit can't go straight into the press. They must first pass through a crucial step, peeling. The machines used for this stage typically handle about 500 fruits per hour, fast enough to keep pace with the production line, yet gentle enough not to crush the delicate flesh. Immediately afterward, the kiwi fruit are chopped into pieces and fed into an industrial grinder. Here, the fruit's cellular structure is carefully broken down, creating a thick puree that releases the maximum amount of juice within. Finally, the filtered kiwi juice is precisely filled into sterilized bottles under controlled conditions, with a volume deviation of less than 2%. As the bottles leave the production line, each one carries the result of precision, consistent quality, and an optimized shelf life, born from accuracy at every preceding stage. Beyond its familiar role in juice, kiwi enjoys a far richer life in the world of cuisine. With its gentle tartness, signature green hue, and smooth texture, it becomes an ideal ingredient for desserts, from mousses and tarts to the delicate topping layers of cakes. Just a few thin slices of kiwi can create a striking visual accent, bringing freshness and vibrancy to any dessert plate. But kiwi's versatility extends well beyond sweets. It is also used in salads, grilled meat pairings, and fine dining presentations, prized for its natural ability to balance richness and cleanse the palate. A small fruit with an unexpectedly sophisticated touch. Each year, global bell pepper production exceeds 38 million tons, with China, Mexico, Turkey, and the United States being the largest producers. As one of the most delicate vegetables in the world, hand harvesting remains the dominant method in many traditional growing regions. Farmers pick each ripe pepper by hand, cutting the stem with scissors or small knives to avoid tearing the skin or breaking the branches. Standard quality peppers are typically red, yellow, or deep green, with smooth, glossy, unblemished surfaces. However, at large-scale farms in Spain, the United States, and the Netherlands, mechanical harvesting technology is being increasingly adopted. Bell pepper harvesters use soft conveyors and vibrating mechanisms to detach the fruit, helping reduce manual labor and double productivity compared to hand picking. Color and size sensors are integrated directly into the harvesting line, allowing preliminary sorting to take place immediately in the field. A further advancement is robotic harvesting in automated greenhouses, currently being tested in Japan and the Netherlands. Robotic arms equipped with AI cameras and 3D sensors can detect the color, ripeness, and position of each pepper, then cut and gently place it into collection trays. Economically, the global bell pepper production and trade industry is valued at more than $60 billion USD annually. In fact, demand for bell peppers continues to grow steadily by 3 to 4% each year, driven by healthy eating trends and the need for year-round vegetable supply in temperate countries. Now, let's explore the papaya harvesting process on a global scale, one of the most widely consumed tropical fruits in the world. Today, global papaya production exceeds 17 million tons per year, with India remaining the leading producer at around 6 million tons, followed by Brazil, Indonesia, Nigeria, and Mexico. Papayas are generally harvested year-round, with peak seasons falling between March and September, depending on the region. The ideal time to harvest is when the skin begins to turn from green to pale yellow, The surface appears glossy, and the fruit releases a subtle fragrance. Harvesters use small knives or gently twist the stem by hand to detach the fruit, placing it carefully into padded baskets to avoid scratches or bruising. For a fruit that ripens quickly and bruises easily like papaya, gentle handling and same-day transport are crucial to maintaining export quality. Thanks to its high yield and continuous harvesting cycle, papaya generates billions of dollars in economic value annually, not only as a fresh fruit, but also through processed products such as juice, jam, and papain enzyme, a key ingredient in the global food and pharmaceutical industries. Indonesia is currently the world's largest pineapple producer, with an annual output of about 3.2 million tons. The main growing regions are Lampung and South Sumatra, where the humid tropical climate and fertile red basaltic soil provide ideal conditions for pineapple cultivation. During harvest season, farmers skillfully cut the fruit close to the base with sharp knives, leaving a short stem to minimize moisture loss. Manual harvesting allows farmers to select fruit at perfect ripeness, preserving the golden hue and preventing bruised eyes, a crucial factor for whole fruit export standards. Properly harvested pineapples retain their sweetness, crisp texture, and signature aroma throughout long-distance transport, reinforcing Indonesia's position as one of the world's leading pineapple exporters. Indonesia's pineapple industry is not only massive in scale, but also vital to the national economy. Export revenues from fresh and processed pineapples exceed $2 billion each year, fueled by strong demand from the European Union, Japan, China, and the United States. Canned pineapples and juice account for a significant share of export value, driven by the global appetite for tropical products. They say the world is divided into two teams, those who love pineapple on pizza and those who would never allow it near a slice. So which side are you on? From the Yunnan valleys of China to the fertile plains of central Chile and across Eastern Europe, millions of plum trees are heavy with ripening fruit. In 2025 alone, global plum production is projected to exceed 12 million tons, serving both domestic markets and international demand for fresh and dried plums. Between June and August each year is the most suitable time for harvesting, when the fruit reaches optimal ripeness and its highest sugar content. Farmers usually harvest early in the morning to preserve freshness, picking by hand or using specialized tools to minimize scratches and bruising. China currently dominates the global plum market, with an output of about 6.75 million tons, accounting for more than 54% of the world's total production. Premium varieties such as Black Amber and Friar are in high demand in Japan, South Korea, and European countries, selling at retail prices 2 to 3 times higher than domestic plums, ranging from $2,000 to $3,500 per ton, depending on the season and quality. With its distinctive fragrance, widely appreciated, but its soft texture, high susceptibility to bruising, and short ripening period, peaches are considered one of the most temperamental fruits in the world. The peach harvest season usually takes place from May to September, depending on the region and variety. Farmers typically harvest entirely by hand, selecting fruits that have just reached commercial ripeness, when the skin turns yellow-orange, emits a light fragrance, and still retains enough firmness to withstand transportation. Each fruit is picked with a gentle twisting motion and placed into padded trays to prevent scratching. Each year, global peach production reaches about 25 million tons, with China, Spain, Italy, the United States, and Greece being the largest producers. Due to the sensitivity of peaches, full mechanization remains a major challenge, especially as appearance and color standards in exports become increasingly strict. Consumption continues to rise in Asian and European markets, particularly in the premium fruit segment, where peaches are regarded as a symbol of summer and freshness. Each year, global banana production exceeds 125 million tons, 5 times that of peaches and 10 times that of plums, making bananas the most consumed fruit on the planet. India, China, the Philippines, Brazil, and Ecuador are the largest producers, with India leading at more than 35 million tons per year, mainly for domestic consumption. In traditional growing regions such as Tamil Nadu and Maharashtra or Los Rios, banana harvesting is still done manually. The work is usually carried out by 2 people. One uses a sharp knife to cut the bunch at the base, while the other supports it from below to prevent bruising. Each bunch can weigh 25 to 30 kilograms, trimmed, sorted on site, and then transported to the processing station. At large-scale farms in Latin America and Southeast Asia, overhead conveyor systems, cable transport, and automated post-harvest handling technologies are widely applied, helping to reduce labor costs and mechanical losses. According to the FAO, more than 400 million people around the world currently depend directly on bananas as a source of income or staple food, turning this humble fruit into a vital livelihood link for hundreds of millions of farming families globally. Instead of being discarded as before, most of this biomass is now efficiently reused in a circular agricultural system. Today, thanks to mechanization, banana stem shredders can process tons of material per hour, turning it into green manure or bioorganic fertilizer, helping to improve soil structure and reduce up to 30% of chemical fertilizer use for the next crop. In India and the Philippines, banana fiber recycling projects have helped reduce more than 200,000 tons of agricultural waste each year, while contributing to carbon emission reduction and promoting sustainable farming models worldwide. Because spraying pesticides by hand takes too much time, we now continue our journey with a high-capacity mist sprayer used in large-scale agriculture. Suitable for many types of crops such as rice, corn, and fruit trees. This device uses a high-pressure jet fan system to disperse pesticide or foliar fertilizer solutions at a flow rate of up to 375 liters per minute, spraying up to 300 meters in just a few minutes. This type of machine is now widely used in large-scale farming areas in South Korea, Japan, Latin America, and Southeast Asia. How do you view this approach to modern agriculture? The watermelon harvest season usually lasts from May to September in the Northern Hemisphere, while in the Southern Hemisphere in countries such as Brazil and Argentina, it falls between November and March, ensuring that this fruit is available almost year-round on the global market. Harvesting watermelons is a delicate balance of strength and precision. Unlike grains or corn, These fruits, often weighing up to 1,000 times more than a strawberry, are far too fragile to be harvested entirely by machines. Most are still picked by hand. Farmers walk row by row, tapping the melons and listening for the hollow sound that signals ripeness. Once a fruit is chosen, they cut the stem with a small knife and gently set the melon down to avoid cracking its thick yet brittle rind. It is a task that demands coordination. If a worker becomes careless or impatient, the heavy fruit can easily be damaged or shattered. Timing is also critical. Watermelons must be harvested early in the morning when temperatures are cooler, preserving their firmness and sweetness. Every year, more than 100 million tons of watermelons are harvested worldwide, with China alone contributing nearly 60% of the supply. People often joke that if you could bring only one plant to a barren land, everyone would choose the banana. Not only because it's incredibly resilient, but also because its productivity is so high that it could sustain humans for weeks. Harvesting bananas may look simple, but it's actually one of the most challenging crops to harvest in the world. A single bunch can weigh 50 to 70 kilograms, heavy enough to knock a worker off their feet if they don't use the right technique. For export bananas, each bunch is wrapped in plastic from the very beginning to protect it from insects and maintain a stable temperature. When the fruit reaches the right age, workers measure the size, curvature, and weight of each hand of bananas, then cut the bunch using specialized tools. Once cut, the unripe green bananas are hung on a pulley system to prevent bruising. From there, they travel along narrow rail lines, pulled by pack horses through the plantation, or transported via cable systems over slopes to the packing station. Have you ever wondered why bananas are always harvested while still green? It's because at that stage, the fruit is firm enough to withstand long-distance transport of thousands of kilometers, ripening slowly under controlled conditions, so the flavor remains perfect when it reaches the consumer. Leaving behind the swaying banana bunches under the low canopy, let's look up to the sky, where coconuts hang high atop towering trees, beginning a new journey, the challenging process of coconut harvesting. Despite their tropical chill image, coconuts injure around 150 people each year when they fall on heads. That height and risk make harvesting coconuts one of the most difficult and dangerous tasks in agriculture. To mitigate the danger of coconuts falling from dozens of meters, farmers came up with a solution that's both simple and ingenious: digging shallow water channels between the rows of coconut trees. Thanks to this water layer, each bunch, once cut, doesn't fall freely onto hard ground, but instead lands softly on the water, where the impact is almost entirely absorbed. A single 50-meter-long channel can safely catch around 2,000 coconuts a day, drastically reducing cracks and breaks, a problem that once cost farmers up to 30% of the crop's market value each season. After harvesting, the coconuts are tied together in long chains and floated along the water like natural buoys. This allows farmers to pull hundreds of coconuts at once along the channel with almost no effort. From above, the entire transport system looks like a riverine logistics chain: smart, gentle, and extremely efficient. Dubbed the sun fruit of the Mediterranean, the lemon has become a staple in the era of clean eating and healthy living. In Spain, over 40% of lemons are still harvested by hand, where skilled hands carefully shape billion-dollar harvests. Amid the dense lemon foliage, workers must gently weave their hands through the leaves to find fruits at just the right ripeness. Instead of tugging or pulling branches, they use specialized scissors to cut the stem at a 45 degrees angle, leaving a 3 to 5 millimeter stem stub, a technique that protects the delicate peel from scratches, a key factor in quality and shelf life. During harvesting, a slight squeeze of the fruit can release thousands of tiny oil sacs on the peel, creating a fine mist that can make the picker's eyes water. Lemons are almost always hand-picked because machinery struggles to separate the fruit without bruising the skin or breaking branches. Moreover, each tree ripens unevenly, requiring pickers to select fruits one by one. Thanks to their skillful hands and years of experience, these workers ensure that each lemon harvest meets the highest standards for both export and processing. With more than 500,000 tons of cherries exported each year, Chile is known as the world's cherry powerhouse, accounting for over 40% of the global fresh cherry supply. When cherry season peaks, the orchards seem to move in a mesmerizing mechanical rhythm. The steel arms of the harvesting machines press gently against the trunk, lock into place for a split second, then shake in a controlled motion for just a few seconds, strong enough to release the ripe fruit, yet gentle enough to avoid damaging the branches. Thousands of deep red cherries cascade onto the catching frame like a rain of sweetness. Each machine setup can harvest 2 to 3 tons of cherries per hour, boosting productivity by 20 to 30 times compared to hand picking, while minimizing bruising thanks to the soft padding on the catch trays. One critical technique is always emphasized. The vibration must stay within the 30 to 45 Hz range, because even a slight deviation can cause unripe cherries to fall as well. Behind the machines, crates fill up rapidly, capturing the full value of a billion-dollar harvest from the most renowned cherry-growing region in the world. As the plant that makes the whole world cry, more than 100 million tons of onions are harvested each year with modern technology. Across vast fields of golden onions at peak season, the harvesting machine roars to life, pulling entire rows from the ground in one decisive motion. Few people realize that behind such power lies a strict limitation. Despite weighing several tons, an onion harvester must never exceed 3 kilometers per hour. Even slightly surpassing that speed can create tiny shocks strong enough to bruise thousands of bulbs, causing entire storage batches to spoil later in a domino effect that's nearly impossible to control. Right after being lifted from the soil, a lift screen air system takes over with near-perfect precision, removing dirt and roots in just 0.2-0.4 seconds before conveyor belts carry the bulbs into the storage hopper. Thanks to this constant rhythm, each machine setup can collect 4 to 6 tons of onions per hour, replacing the labor of dozens of workers and turning the entire field into a true open-air industrial assembly line. And from that overflowing hopper, waves of spotless onions are unloaded onto transport trucks, beginning their next journey to the processing plant, where they are cleaned, sorted, and moved into an even more sophisticated technological system. With a harvest season lasting only 40 to 45 days, lychees have become a symbol of fragility and uniqueness, as more than 3 million tons are picked during the most vibrant race of the summer. In June, bright red lychee orchards enter a brief 40 to 45-day harvest window. Lychees must be picked at night or early in the morning, when the fruit is still asleep. Its respiration slows, and its internal temperature stays around 25 to 27 degrees Celsius. Conditions that help preserve the red color and crisp texture before they are chilled. During the day, lychees release heat intensely. Just a few hours under the sun can darken the peel and diminish their quality. On lower branches, the fruit is clipped quickly and gathered in clusters, while on the higher canopies, workers must climb to the treetops or use long poles to lower each bunch without scratching the delicate skin. In November, as Florida's mandarin orchards ignite in a brilliant shade of orange, citrus harvesters roar to life, marking the start of one of the most powerful and precise mechanized processes in the U.S. citrus industry. Unlike fresh mandarins, which must be hand-picked, most industrial mandarins used for juice and essential oils are harvested entirely by machine. Nearly 3-meter-tall citrus harvesters drive between the tree rows, using hydraulic shakers to vigorously rattle the canopy and release the ripe fruit. The mandarins fall onto conveyor belts below and are carried straight into the holding tank, never touching the ground, not even for a second. Thanks to mechanization, each machine can collect 20 to 40 tons of mandarins per hour, clearing an entire orchard in just one morning. Despite its efficiency, the shaking system can bruise 10 to 20% of the fruit, knock down immature mandarins, and strain the branches, turning every harvest into a calculated trade-off.